everyone. In today's lesson, we are going to learn about the properties of logarithms. We are going to learn how to expand logarithms, condense logarithms, and use special quantities or special relationships of logarithms in order for us to come up with actual answers. Before we get started though, I want you to please go ahead and simplify the following expressions on your own. We have b to the mth times b to the nth. We have b to the nth power divided by b to the nth power. And we have b to the nth power raised to the nth power. Please use your properties of exponents in order to simplify each expression. And when you have an answer, I want you to go ahead and restart the video and we'll see how well you did. Okay, whenever you multiply two powers with the same base and they're both being raised to an exponent, we know that the property says that we add our exponents. So our answer would be b to the m plus nth power. Next, we know if we divide two powers with the same base and they both have exponents, we're going to subtract the exponents, top minus bottom. So our answer is b to the m minus nth power. And for number 3, we know that if we're raising a power to a power, we use the distributive property with respect to the exponents. So our answer is b to the m times nth power. And that is the answer for each of these expressions. And we're going to use these properties for logarithms to help us with expanding as well as condensing logarithms. So our learning targets for today is I can expand and condense logarithmic expressions using the properties of logarithms. And then we're going to apply it to actual numbers a little bit later on in the lesson. So the first property that we have is the product property. And it says that if you have log base b of m times n, what we saw up here is when we multiplied two powers with the same base, we added the exponents. Well, if you're multiplying two numbers together in a logarithm, the way to expand it is to take the log base b of m and add it to the log base b of n. So the expanded form, whenever you see multiplication, is to separate and take the log of each factor. So we're going to take the log of m and add it to the log of n. Next, there's the quotient property, and whenever we divided two powers with the same base, we subtracted the exponents. So the quotient property says that if you're taking the log base b of something that you're dividing, the way to expand is to take the log base b of m minus the log base b of n. So whenever you're dividing, the expansion is subtraction. And then next, we had, whenever you had a power to a power, we ended up distributing our exponents. So our power property is if you have something that is being raised to a power, like log base b of m to the nth power, this exponent is going to come out in front. So our expanded form is going to be n times log base b of m. So our expanded form is going to be using multiplication. These are all called expanded forms, and what you're going to see is you're going to see directions that will ask you to expand your logarithm, just like in number 1. Example number 1 for A, B, C, D, and E, we want to expand each of the logarithms. We want to expand it completely, which means that we might be working with multiple properties at a time. So what we have in number 1 is log base 3 of 3x to the 6th power y to the 1/2 power. And what we have here is multiplication. So the main thing here is multiplication, and I'm going to take the log of each piece that I am multiplying. So I'm going to write log base 3 of 3 plus log base 3 of our next piece, which is x to the 6th, plus log base 3 of the next thing I'm multiplying, which is y to the 1/2. Now we are almost done simplifying. Each part can be simplified even further. So log base 3 of 3 to the 1st power, we can use that property of log base 3 of 3 to cancel it out, and their answer is going to be the exponent. So that's going to equal the number 1. Plus, we have log base 3 of x to the 6th power. There's a power right here, so that means I can bring the 6 out in front using multiplication. So 6 times log base 3 of x. Plus, once again, I have an exponent of 1/2, and I can bring that out in front because we're raising it to a power, and we can use the product property. So I'm going to have plus 1/2 log base 3 of y. And that is my complete expanded form. So what I did is I separated using addition signs because I needed to separate based on what was given to me. And then I simplified each logarithm individually based on whatever the expression was. So now let's go ahead and look at letter B. For letter B, the main operation that's taking place here is division. So my first expansion is going to be to use subtraction. I'm going to write log of 7y to the 3rd minus log of 4x squared. Now I'm going to work with each logarithm individually to expand it even more. So I'm going to have log, well, I have multiplication here, 7 times y to the 3rd. So I'm going to write log of 7 plus log of y to the 3rd minus, be careful right here, I'm going to put parentheses around what I'm about to expand. So when you expand this, I want you to please be careful and use parentheses so that you don't end up with a sign error. So I'm going to rewrite this as log of 4 plus log of x squared. Now I'm going to work with each term individually and then eventually distribute that negative to each term. So log of 7 I cannot simplify, so I'll just rewrite it as log of 7. Plus, we have an exponent next door to the y to the 3rd, so that y to the 3rd is going, or that 3 is going to come out in front. So I have plus 3 log of y. Minus, I'm going to distribute, and I have minus log of 4. I can't do anything about it, but I do have this 2 that's attached to the x, so that's like x squared, and that 2 will come out in front. So I'm going to have minus 2 log of x. So what I did is I distributed that negative, and then I brought the 2 out in front. And this is our complete expanded form. A lot of times kids will ask me, do you have to show all of that work? And the answer is no, but the more work that you show, the more partial credit you qualify for. Let's go ahead and look at letter C. For letter C, the main operation that's taking place here is multiplication. So the first expansion that I'm going to use is addition. I'm going to expand using addition. So this is log of m squared plus log of n squared. Now, both of these expressions have exponents, so the exponents will come out in front for both pieces. So my answer is going to be 2 times the log of m plus 2 times the log of n, and that is the complete expansion of this expression. What I would like you to do at this time is please go ahead and try letter D and letter E on your own. See if you can expand those, and when you have an answer, go ahead and restart the video. I strongly recommend, though, that if you have yourself a root, change it to a fraction exponent so that you can use your properties. All right, let's go ahead and see how well you did. For letter D, what I would recommend that you do first is rewrite this as log of m to the 1/3 power, because that's what cube root really means, is m is something to a 1/3 power divided by n to the 4th power. Now, the main operation that's taking place here is division. So we're going to start off by expanding using subtraction. So this is going to be log of m to the 1/3 power minus log of n to the 4th power. Both of these expressions have exponents, so I'm going to bring those exponents out in front, and my answer is going to be 1/3 times the log of m minus 4 times the log of n, and that is the complete expansion of this logarithm. That is letter D. For letter E, The main operation that's taking place here is multiplication, but before I do that, I'm going to rewrite this problem as log of m to the 4th power times n to the 1/2 power. So I'm going to expand using multiplication, or using addition because we have multiplication, and I have log of m to the 4th power plus log of n to the 1/2 power. Anything with an exponent is going to come out in front, so I'm going to bring my exponents out in front, and I have 4 times the log of m plus 1/2 times the log of n, and that is the complete expansion of our logarithm. So that's how you expand. So now, naturally, the next idea is to condense. We can condense using our properties and essentially working backwards. So you want to simplify as much as you possibly can with a lot of these problems. Working with that main operation and noticing or recognizing when you have exponents is essentially the most important thing here. Always start from left to right and try not to do too many steps at once, otherwise you might not get the correct answer. So I'm going to start off at the beginning. I have log of 2 plus 3 times the log of 2 plus 3 times the log of 3 minus the log of 9. So what I'm going to do first is I'm going to recognize that I have a plus sign and I have this 3 on the outside, and that would make that a 3 to the 3rd power. So I'm going to condense my first 2 logarithms first, and I'm going to rewrite this as log of 2 times 3 to the 3rd power. So I'm going to write minus log of 9. So I've condensed the first 2 together, and now I have this minus. And what minus indicates is a division. So what I have here is I have log of 2 times 3 to the 3rd, which is 27, over 9. Well, now I can simplify this expression even more. 2 times 27 is 54, so this is log of 54 divided by 9, and 54 divided by 9 is 6. So my answer is log of 6. There is nothing more for me to do. I simplified my expression as much as I possibly could. Do not do too many steps at once. Like I said before, just do a couple at a time so that you can end up with the correct answer. One of the biggest mistakes students make whenever they're condensing is they do too many steps all at once and they end up making errors along the way. So looking at letter B, I'm going to condense the first 2 terms together. They're being expanded using addition, so that means I'm going to multiply them together. Also, there's a 2 on the outside of this ln of x, so that means that it's the exponent of x. So when I expand the first 2 terms together, I'm going to have the natural log of 3 times x squared. And then I'm going to write minus the natural log of y. So because we're expanding using subtraction, that means that we divided 3x squared and y. So this is going to be the natural log of 3x squared divided by y. And there is nothing further for you to do. This is simply your answer. Your goal whenever you write a condensed form of a logarithm is to have just one log. If you have multiple logs, you did not get it correct. You did not do the process correctly. Your goal is to condense it down to one log. Let's go ahead and look at number 2. For number 2, I'm going to condense because we have the main operation being addition, and I notice that I have 2 x sets of exponents. I have a 2 on the outside that would make this an x squared, and I have a 1/2 on the outside that would make it a y to the 1/2. So I'm going to write this as log base 2 of x squared times y to the 1/2 power. So I condensed the addition using multiplication. Now I can simplify or rewrite that y to the 1/2 power using roots. So my condensed form is going to be log base 2 of x squared times the square root of y. It's better to write your answer using roots because that's how you're going to see original problems given to you, just like we did in example 1, letters D and E. You'll receive, or you're going to be given problems that will have roots around them instead of fraction exponents. All right, letter D. I strongly recommend that you go ahead and try letter D on your own. Pause the video, see if you can do it. And when you have an answer, go ahead and restart the video and we'll see how well you did. All right, so looking at our very first one, there's a negative on the outside, which indicates that we have a -1. So that -1 is actually our exponent. So I'm going to raise 12 to the -1st power, and then I have a 2 on the outside of a log base 5 of 10, and that's going to be the exponent of 10. So I'm just going to combine the first two terms together. So this is going to be a log base 5 of 12 to the -1st power times 10 to the 2nd power, plus we have log base 5 of 3. So now I'm going to simplify 12 to the 1st power and 10 squared as 100 divided by 12. And I'm going to multiply by 3 because we're expanding using addition, so we'll condense using multiplication. So I'm going to rewrite this as log base 5 of. This expression right here is going to be 10 squared, which is 100, divided by 12 to the -1st power, which is 12. So that part was brought down essentially, times 3. If you want to write that as 3 over 1, that's not a big deal. But 3 and 12 have something in common. 3 can go into 12 4 times. So this is log base 5 of 100 divided by 4. And 100 divided by 4, that is equal to 25. So this is log base 5 of 25. It might feel like you're done, but you're really not. And that's because 25 is something that's special. 25 and 5 are related to each other. So this is going to equal something. You can call it a question mark, you can call it x, but what we can do is rewrite this in exponential form to make that 5 to some power is equal to 25. Well, we know that 25 is actually 5 squared. So I'm going to have 5 to some power is equal to 5 squared. That some power is 2. So log base 5 of 25 is actually equal to 2, and our most simplified form is the number 2. That would be your answer. What does log base 5 of 25 equal? It equals the number 2 if we were to keep condensing it down. So then in that case, our answer is 2. We have a couple more examples, and then we are finished for today. So now what I'm going to do is I'm going to tell you that log base 5 of 4 is equal to a certain decimal. And I'm going to tell you that log base 5 of 9 is also equal to a certain decimal. And we want to evaluate, which means that we're going to be working with a calculator to evaluate the logarithm. Our answer is going to be simply a number. So log base 5 of 4 and log base 5 of 9, those are like our clues, numbers that are special that we get to work with. So what we have here in example letter A is we have log base 5 of 4 divided by 9. So what we're going to do is we're going to expand, use our properties to expand this expression. This means log base 5 of 4 minus log base 5 of 9. So we know that log base 5 of 4 is equal to 0.861. So I am going to replace log base 5 of 4 with 0.861. I know that log base 5 of 9 is 1.365 because that was given to me. So I'm going to replace log base 5 of 9 with 1.365. Now, using my calculator, I'm going to subtract these numbers and come up with an answer. And that's going to be negative 0.504, rounding it to the nearest thousandth, if necessary. This will be your answer. So all we did here is we used our properties to come up with some sort of form of log base 5 of 4 and log base 5 of 9. I replaced those expressions with the numbers that were given to me, and I was able to come up with an answer. Let's look at letter B. Well, letter B, they gave us the number 36. So you kind of have to think outside of the box. How can you use the number 4 and the number 9 to get the number 36? Well, we know that 36 is actually 4 times 9. So 4 times 9 is 36. So what I'm going to do is I'm going to use that multiplication and expand using addition. So I'm going to rewrite this as log base 5 of 4 plus log base 5 of 9. So what I did is I used that number 36 as well as the clues that were given to me, and I had to come up with some sort of clever and creative way to use those numbers and make this answer work to my advantage. So I know that the log base 5 of 4 is 0.861, and I know that the log base 5 of 9 is 1.365 because that was given to me in the directions. So when I add the two numbers together, I end up with 2.226. Letter C, we have log base 5 of 81. So there are actually two approaches for this problem. Now, we really can't use the log base 5 of 4, and that's because 4 can't go into 81. But what we can do is we can say that 81 is 9 times 9. So I can write this as log base 5 of 9 times 9. So I can expand by saying log base 5 of 9 plus the log base 5 of 9. So that's going to be 1.365 plus 1.365. And when I add those two numbers together, I end up with 2.73. That's one approach. Another approach is to say, well, I know that 81 is really 9 squared. So we can bring that 2 out in front and make that 2 times log base 5 of 9. So that's really 2 times 1.365. And when you multiply 2 times 1.365, you also get 2.73. So both approaches will still get you the right answer. So the point of me showing you both approaches is for you to see that maybe you see something different than somebody else. You can still get the right answer using your own approach. I want you to go ahead and try example number 4 on your own and try to come up with clever ways to expand. We have log base 3 of 32, and we have log base 3 of 16. Go ahead and try those problems on your own, and then we'll see how well you did. All right, so 32, there's a lot of approaches that you could do. Some people might see that the number 32 is 2 to the 5th power and write that as log base 3. 32 is 2 to the 5th. Well, we can bring that 5 out in front and make that 5 times log base 3 of 2. So that's 5 times 0.6309. And when you multiply those two numbers together, you end up with 3.155, rounding it to the nearest whole number, or nearest thousand, excuse me. That's one approach. You could have also seen that 32 is 4 times 8, and 4 is 2 times 2. So you could have written this as log base 3 of 2 times 2 times 8. So that would be log base 3 of 2 plus log base 3 of 2 plus log base 3 of 8. And therefore it's 0.6309 plus 0.6309 plus 1.8928. And if you add all of those numbers together, once again, you should end up with 3.155. Both approaches will get you the right answer. It just depends on what you see. And maybe you approached it in an even different way. Maybe you made that 2 a 2 squared, and you brought that the square out in front using the product property. That's fine too. Regardless of your approach, you should have ended up with 3.155. Now we have log base 3 of 16, and I know that 16 is 2 to the 4th power. So the fastest way that I know is to write this as log base 3 of 2 to the 4th. Bring that 4 out in front, so we have 4 times log base 3 of 2. So that's 4 times 0.6309, and that is equal to 2.524 when you put that into your calculator. That's one approach. You could have also said that 16, that's equal to 8 times 2. So you could have log base 3 of 8 times 2, which is log base 3 of 8 plus log base 3 of 2. Log base 3 of 8, that's approximately 1.8928 plus 0.6309. And when you add those two together and round to the nearest nearest thousand, you would still end up with 2.524. No matter your approach, and maybe you approach it in a different way, saying that 16 is 4 times 4, and then change both of those to 2 squared and 2 squared. Whatever your approach is, it's not wrong as long as you're able to get to the right answer and you're able to use the pieces or the clues that they give you. That is the end of 7-5, day 1. If you have any questions over anything, please feel free to email me. Otherwise, I will talk to you next time.